The last part of section 2.3, we're going to study linear situations and how it applies to some things in real life. And you have a supplemental worksheet where there's 6 different problems that deal with certain situations in life that are all linear. And the goal is, as your directions say at the top, letter A, write a linear equation in slope-intercept form. B, draw a graph that will model this situation. And C, answer any questions regarding the given situation. And that's basically the main purpose of this, is to answer and make predictions regarding a situation if it's linear. So, let's do number 1 together. The office manager of a small office ordered 140 packs of printer paper. Based on average daily use, she knows the paper will last about 80 days. And the first thing it says is write an equation. And it's got to be linear. So therefore, we know our equations in the form y equals mx plus b. Therefore, from this particular section, we all know you need to figure out what the slope and the y-intercept is. Well, let's talk about the slope. First of all, we all know slope is equal to change in y over change in x. Now, in this particular situation, and also in most linear situations, slope is given away in a problem by the word per. If you see the word per, that's a dead giveaway that that number is the slope. So for instance, if they tell you gallons per minute, or if they tell you miles per hour, that is the slope because that's the rate of change. The word per is basically how much for 1 unit. And you may want to write this in your notes. How much for 1 unit of something. And usually the x value, anytime you deal with time, the x value usually has something to do with time. So that's going to be very, very, very important. So if you want to pause the video and write down a few of those notes, go ahead, because I'm going to erase them. And we'll continue onward. So, since slope is the word per, x in this case is probably the days, since that's time. That leaves the packs of paper as the other variable, which would be the y variable. So what we're basically looking for is we're trying to figure out a slope, that is, how many packs per day is used. Well, very simply, packs per day would be 140 packs divided by 80 days. And if you actually work that out, that comes out to be 1.75. So therefore, my equation can start out y equals 1.75x, because x will stand for how many days, and y would be how many packs of paper. Now, we need a y-intercept. So the question is, as we learned earlier in this particular section, what is the y-intercept? Well, the y-intercept is when x is 0. And what's the answer for y? Well, obviously, very simply, if 0 days have gone by, just common sense says you've used 0 packs of paper. So therefore, there should be a plus 0 at the end of this equation, which we don't write, but that would be basically what the y-intercept is. And there's our equation, y equals 1.75x. And I'm going to circle that, just so we continue to use that. All right, letter A. Graph this situation on a piece of graph paper. Well, I've already got us started. So if you would like to pause the video and copy this graph down, that would be great. And if you notice, the x value is days, which we've already established, and the y value is packs of paper. All right, let's finish our graph. In order to finish the graph, we know it's a linear situation, so it forms a line, but we need some data. And what do we know about x and y so far? Well, we know a couple of things. Number one, we know the y-intercept is 0, and that happens at 0 days. So 0, 0 should be a point on our graph. Now, we need at least one other point so we can form a line. Well, it did tell you also that 80 packs of paper, or I'm sorry, 80 days, in 80 days they use 140 packs of paper. So that particular piece of information is also on our line. So I go over to 80 and up to 140 and put another dot, roughly about there. Now, if we wanted a third dot to help us, we could pick pretty much any value for x and plug it into our equation, y equals 1.75x. So let's use the number 40. Let's use half of that. Now, we could put it in the equation, or we could just use what we know about linear equations and tables, and that the change has to be consistent. Therefore, 40 is half of 80, so 70 must be half of 140. So also the point 40, 70 is on our graph. So I go up to 40, or go to 40 and up to about where 70 is, and the dot would be about right there. Now, assuming I did this correctly, I should be able to draw a fairly straight line that will connect those two dots. Make it a little better for us. And there is the linear graph of our situation. So let's go back to the questions that we're supposed to answer. The question says, letter B, according to the information in problem 1, how many days will it take to use 50 packs of paper? So you could use your equation and figure it out, but the key word says about. And so I'm just going to use my graph. Now what I'm going to do is I'm going to go find where 50 packs of paper is, which must be somewhere about right there. And I'm going to go over to my graph, to my line, and I'm going to go down. And it looks like somewhere, if I did that correctly, somewhere around the area of about, maybe 27, 28, 27, somewhere in here. And again, it's an estimate when you use your graph to answer the questions. You want to do as accurately as you can. So going back, I would say, well, about 27 days would maybe be a good estimate based on my graph. Now, you may have a slightly different answer on your graph, and that's fine. Looks like I've got a lettering problem, but let's go to the second letter B here. How many packs of paper will be used in 100 days? So again, we're going to go back to our graph, and we're going to find 100 days. Now, that's off my chart. Here's about where 90 would be, and here's about where about 100 would be. So I'd have to go up to my graph, and obviously I'm off the picture, and I work my way over. Or I could just take 100 and put it in for x into my equation, and if I did that, I would find out that y is roughly about 175. So in about 100 days, we would use about 175 packs of paper. The last question, which is probably new to a lot of you, is this a direct variation problem? Now, in order to answer what a direct variation problem is, it's very simple. And I'm going to go back to our little chart, and I'm going to move ahead, and you may want to copy this down. Direct variation very simply means the y-intercept is equal to 0. A direct variation form of a linear equation is just y equals mx. There is no plus b part. So the question is the y-intercept equal to 0, or is the point 0, 0 on your graph? And that's what direct variation means. So, obviously, if I go back to the graph, you're going to see that 0, 0 is there. Also, you can tell from your equation. So therefore, the question that we answer, is this a direct variation problem? The answer is yes, and the reason is because the y-intercept is equal to 0. And that is how you solve these particular word problems. First, by writing the equation, figuring out the slope, and that slope usually means per, and using your variables, y over x. And then secondly, by writing a graph. And third, using that graph like we did in the two-letter B's to make predictions. And that's the purpose of linear equations in mathematics.